Well, hello. Let's see if we can hide this little window. Hi. So, this is just going to be a quick rundown of some Continental Drift stuff, and we'll come back to things, and this will all follow up with a video, but I thought we should talk about a few things. I wish we could converse about it. So, today we're going to talk about Continental Drift. This is Abraham Ortielis. He originally was the first person, at least in Western literature, to suggest that the continents probably fit together at one time and were all together at one point. He was a cartographer or map maker. He created one of the first major atlases or maps of the world, a whole book of them. And when he was looking at them, he realized that it looked like at least South America and Africa fit together. This is a major breakthrough for him, and why other people thought he was a little off his rocker. He was right. But he was the first to suggest it. Like 400 years later, or a little less, this gentleman would come along. This is Alfred Lothar Wagner, Dr. Wagner. He was a German meteorologist. He specialized in climatology, particularly polar climates and cold climatic conditions. He was born, and you can't read this, of course, because of the dueling screens, was born November 1st, 1880, and died sometime in mid-November of 1930. He died on an expedition in Greenland where he was doing polar research, looking for more evidence, not just of polar climates, but for his hypothesis for continental drift, which we'll get to in a moment. He was out searching for food with his friend Erasmus. They were heading out for their last encampment. He never made it. He disappeared somewhere in the frozen tundra. His body still unfound. I guess you win some, you lose some. I don't know. Kind of rough. But he died in the name of science. So we got to owe him that. And he was the first modern Western scientist to suggest that the continents fit together and at one point had been together and would drift apart. He was the progenitor of the idea of continental drift. And he would use four major pieces of evidence to support his hypothesis. The first was the idea that continents fit together like puzzle pieces. And you should be writing this down. You should write this down. You get this guy's name, Alfred Lothar Wagner. Look him up. He was in the exploration questions, and he's going to be talked about in the video you're going to watch after this. Yeah, he said these look like they fit together, not just here, but around the globe. That you could kind of mesh them back together like a puzzle and create a single giant landmass. This is his first piece of evidence. The next piece of evidence was fossil evidence that only made sense if the continents were connected. In particular, he pointed to this guy, the Mesosaurus. The Mesosaurus. The Mesosaurus the fossils were only found on the east coast of South America and the west coast of Africa, which meant either this freshwater reptile was hopping across the ocean or teleporting, or the continents were together while this animal existed. Made a lot more sense. And when he went back and looked at the other fossils, and the only way it made sense was if these land masses were connected into one another. So fossil evidence became the next big piece. This is a drawing of a Mesosaurus skeleton, just for kicks, I guess. The next major piece, our third piece of evidence, was climatic evidence. In particular, glacial evidence. Being a glacial polar scientist, well, this was his specialty. He knew what he was talking about. And he looked back at the glacial evidence, and at one point during the Paleozoic? Yes, the Paleozoic, there was a giant glacier that covered all these land masses. in these areas. And you can see evidence of their movement through glacial striations. And that's where a glacier is carrying a little piece of rock along with it and scrapes a straight line into the soil or rock beneath it. And all the glacial striations were suggesting that they were all moving apart like this. Now, either the glacier covered the whole southern half of the ocean, or at one time these pieces of land were together and fit together. Made a lot more sense that this would be together, especially when you looked at striation angles and you started to reline things. There was also warm climatic evidence where he found coal beds that only would have existed in warm climates, but were now found in places where there was freezing cold and in cold climates where those things never would have formed. So they had to be in a different position when those formed. Again, the third piece of strong evidence was climatic evidence. And then finally, we have the rock evidence itself. If you go back and look at these mountain ranges, the Appalachians, they actually extend from northern Africa up through Georgia, across the United States and northeastern Canada, across Greenland, England, Scotland, and way up here into Norway and Sweden. Identical rocks across all these places. Now, they may have formed separately, sure, you could have that, but not only were they identical, they were in the exact same order, which meant they had to form at the exact same times, in the exact same order. The only way that works is if they're forming together. Again, all this was very powerful evidence for what Alfred would come to call Pangea. He suggested that about 250 million years ago, the Earth was all on this one giant, all the continents, the Earth, all the continents were together in this one giant landmass, surrounded by this one giant sea. So this was Pangea. And in Greek, this means all land. And the Panthalassic Sea meant all waters or all oceans. So he was saying that there was one continent and one ocean. He published this idea in 1912, and it was met with a tremendous amount of skepticism, to the point he kind of got laughed off the stage, and other scientists, geophysicists, were like, stick to the cold and what you know, Alfie. Stick to what you know. But he was like, I can't let this go. I know it's true. I know it. And he kept digging for evidence that the continents would eventually be in this position and have moved there from that original Pangea position to here. But he had no mechanism. There was no way to explain how it got there. This is just a crazy explanation. People were suggesting all kinds of things. I thought this one was funny. We had no way to figure this out. And it wasn't until post-World War II that we would know how to do this. So, I want you to watch the next video. And then you should be able to figure out how to answer those questions. And we'll talk about what happens next when we're ready to talk about what happens next. So take care of yourselves. I hope you enjoyed this, and I'll see you soon.